Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to design rectangular microstrip patch antenna at a 2.4 GHz operating frequency. And this is the structure of the microstrip patch antenna. In order to design any microstrip patch antenna, have to consider three parameters. And the first thing is operating frequency or the resonant frequency. And the second one is height of the substrate, and third thing is type of the substrate material. In order to design any microstrip patch antenna, initially you have to consider these three things. First one is operating frequency, second one is height of the substrate, and third one is type of the substrate material. And this is the ground plane and this is the substrate. Small h is the height of the substrate. So on the ground plane we can design substrate. On the top of the substrate we can design patch antenna. So this is the schematic structure of the microstrip patch antenna, and this is the top view of the microstrip patch antenna. So first we can calculate the design formulas, design equations of the rectangular microstrip patch antenna, rectangular patch antenna width and length. So now here in this design I am considering the operating frequency is 2.4 GHz operating frequency, and the type of the material I am considering FR4, and its relative permittivity constant is 4.4, and I am considering height of the substrate is 1.2. And using rectangular microstrip patch antenna design equations, we can calculate width of the patch antenna and length of the patch antenna. So the width of the patch antenna is 38.03 and length of the patch antenna is 29.51 mm. Width of the patch antenna is 38.03 mm and length of the patch antenna is 29.5 mm. So now open the HFSS software. So click on the insert HFSS design or go to the project, click on insert HFSS design, and after that save the project name. Right click on this project, click on save as button and select your suitable location, and after that give the name, and my project name is rectangular microstrip patch antenna. Click on the save button. So now here we can design the rectangular microstrip patch antenna. First we can design the ground plane. On the top of the ground plane we can set substrate. On the top of the substrate we can design rectangular patch antenna. So first here I will design ground plane. So draw the box, draw the box, click on at any position on the plane and click in this position. This is the box, and double click on this box one, give the name. That name of the box is ground plane, and the type of the material is, here I am selecting the ground plane material is copper. Click on the OK button. If you want to change the color, select your interested color, and after that change the dimensions of the ground plane. So double click on create box. This window will appear on the screen. So now here the position and exercise. So now here the patch antenna width is 38.03 mm and length of the patch antenna is 29.5 mm, and this is the width of the patch antenna and this is length of the patch antenna. So at 2.4 GHz operating frequency, so the length of the patch antenna is 29.5 mm. So if you have to consider approximately 30 mm, and the width and length of the ground planes are 2 times of the length of the patch antenna. So 2 into 30, 60. The length and width of the the length and width of the ground plane and substrate length and width I am considering 2 into 30, 60 mm. And exercise is 30, 60 mm, and Y size is 60 mm, and the ground plane thickness is 0.05 mm. The ground plane thickness is I am considering 0.05 mm, and X position is minus 60 by 30, minus 60 by 2, and Y position is minus 60 by 2, and Z position is minus 1.25 mm. So click on the OK button. So fit the screen. So this is the ground plane. So this is the ground plane. And this is the substrate. And this is the ground plane. So this is the ground plane. On the top of the ground plane, you have to consider substrate. And on the top of the substrate, we have to consider microstrip patch antenna. This is the line feeding microstrip line. And this is the patch antenna. This is substrate. And this is ground plane. And this is the height of the substrate. Now the height of the substrate is I am considering 1.2 mm, and this width is 0.05 mm. So this ground plane width is, so this is 0.05 mm. So this is along the z axis, and this is the origin. So from this point to this point, 0 to 1.2, so 1.2 plus 0.05, so 1.25. So now here the z portion is minus 1.25. So that ground plane is uh, below the center portion, and this is the center portion, and this is the origin portion. Okay, so that ground plane is located in from the from the origin minus 1.25 mm. So what is that 1.25 mm from the center portion? This is the center portion. From here to here is 1.2 plus 0.05. So 1.25. So that is below the origin. So that is minus 1.25. That is the jet portion. And here this value is, and this is the origin point, and this value is, this is 0.25. 0.05. This is origin, and this is the side view of the rectangular microstrip patch antenna. This is the side view of the rectangular microstrip patch antenna. So on the top of the ground plane, we can design substrate. So the substrate dimensions are same as that of the ground plane. Select the box, draw the box, and double click on this box one. Give the name. That name of the box one is substrate. And now here the substrate material is, I am selecting FR4 material, FR4 epoxy, and its relative permittivity constant value is 4.4. Click on the OK button. And if you want to change the color, select your interested color. So click on the OK button. So on the top of the substrate, on the top of the ground plane, you can design substrate. So now change the dimensions of the substrate. So double click on this create box one. So now here the ground plane width is 60 mm, Y size is 60 mm, and Z size is 1.2 mm. The height of the substrate is 1.2 mm, and the X position is minus 60 by 2 minus 30, and Y position is minus 60 by 2 minus 30 mm, and Z position is 1.2 mm minus 1.2 mm. So that minus 1.2. So now we are that substrate is below the origin. So that is minus 1.2. So now click on the OK button. This is the substrate. So on the top of the ground plane, we can design substrate. So on the top of the substrate, we can design microstrip patch antenna. So draw the box. So double click on this box one. Give the name. That name is patch. Patch, and type of the material is same as the ground plane. So ground plane I am considering copper material. Here also patch I will select copper material. If you want to change the color, select your interested color. So click on the OK button. So double click on the create box. Change the dimensions of the patch antenna. So at 2.4 GHz operating frequency, the length. So the length of the patch antenna is 29.5. Width of the patch antenna is 38.03 mm. Width of the patch antenna is 38.03 mm. So that is along the x-axis. So that is along the. So now here this is the center portion. This center portion. So this is x-axis and this is y-axis. Okay, this is y-axis. So along the y-axis, the width of the patch antenna is 29.5. Width is 38.03 mm. Now here X size is length 29.5 mm and Y size, and along the Y size is width, so that is 38.03 mm. So round figure I will take 38 mm, and that patch antenna is placed above on the top of the substrate. So on the top of the substrate, this top antenna is located at a distance of 0.05 mm. So that jet size is 0.05 mm, 0.05 mm, and after that locate the position. So the X position is 29.5 mm. So 29.5 is minus 14.75, and Y position is minus 38 by 2. So minus 38 by 2 minus 19 comma, and Z portion is center portion 0 mm. So click on the OK button. So this is the rectangular patch. The rectangular patch is placed on the top of the substrate. So now the ground plane I selected the color is yellow color. So on the patch antenna also I will take same color. Okay, that material is copper material. So ground plane and patch material is here. Here I am selecting copper material. So ground plane, substrate, patch. And there are different types of the feeding techniques: microstrip line feeding technique, insert feeding technique, coaxial feeding technique. So now here we have to consider, I am considering microstrip line feeding technique. So draw the box, draw the microstrip line feeding technique, and this is feed line. Click on the OK button and change the dimensions of the feed line. So the feed line dimensions and X position this is the X position, and this is 29.5 mm, that X. So this ground plane is 60 mm. And position is, first we have to consider position. This is 60 mm. So that X position is we have to consider here minus 30 mm, and Y position is minus 1 mm, and Z position is 0, and X size is 60 mm, and Y size is 2 mm, and Z size is 0.05 mm. Click on the OK button. So and after that unite the microstrip feed line and patch. So now here first select the patch antenna, that is the patch, and this is the microstrip. Press the control button and after that select the feed. Okay, first select the patch and press the control button, and after that press the microstrip feed line. microstrip feed. So first select the patch, press the control button, and after that press the microstrip feed line. So click on the unite. Click on the unite. So now here the microstrip feed line and the patch are not unite. Now the line is there. So now click on the unite button. Okay. So this is a rectangular microstrip patch antenna on the top of the substrate. And after that, assign the port. Assign port. And this is the XY plane. We can assign the port in YZ plane. YZ plane. So zoom this one. So take the rectangular sheet. Draw the rectangular sheet. So from field line to the ground plane, and give the dimensions of the microstrip that port, and double click on this rectangle one. Change the name of the rectangle. Name is port. So click on the OK button. Now change the dimensions. So this rectangular port dimensions are: position is minus 30 mm, and Y position is minus 1 mm, and from ground plane to top of that Z position is minus 1.25 mm, and this is the ground plane. This is the substrate. From this position to from ground plane this position to here origin, that distance is 1.25 mm. So that is below the origin. So that is minus 1.25 mm. Minus 1.25 mm. And axis is along x-axis, and Y size is 2 mm, and Z size is, so draw the port from ground plane to the patch antenna. So now here this position, or from this position to this position is 1.25. So that 1.25 plus another 0.05. So 1.25 plus 0.05 is 1.3 mm. So this is 1.3 mm. So click on the OK button. So draw the rectangular sheet from ground plane to the patch. So this is the patch, and this is the ground plane, and this is the rectangle. That rectangular sheet attached from ground plane to the patch. So now assign the lumped port. Select the rectangular sheet. So right click on the rectangular sheet. Assign lumped port excitation. So click on the next button. So draw the new line, select the new line, draw the line from center position of the port to the center position. Click on that center position, draw the line from that position to the top of the rectangular sheet of the center position. So click on this position. Click on the next button, finish. So the lumped port is successfully assigned. Now here we will check the lumped port. This is the lumped port. That lumped port is successfully defined. And after assigning the lumped port excitation, so take the radiation boundary. That radiation boundary is selected outer face of the outside of the this structure. Consider radiation boundary outside of the structure. So draw the box, click on any position on the double click on that box one. That name is radiation boundary. And generally you have to consider that radiation boundary type of the material is air. Here I am selecting air material. Click on the OK button. If you want to change the color, select your interested color. And I will give the transparency of the box is 0.9. So click on the OK button and change the dimensions of the rectangular box. Double click on this rectangular box. So now here the dimensions of the rectangular box, and the width of the substrate and height of the substrate is 60 mm, and the dimensions of the x size and y size, z size dimensions of the radiation boundary we have to consider 2 times of the width of the substrate, width of the ground plane. So ground plane width is 60 mm, 2 times of the width of the ground plane is 2 into 60, 120 mm. So now here the x size is 120 mm and y size is 120 mm, z size is 120 mm, and position is 120 by 2. So minus 120 by 2 is 60 mm, and y position is minus 120 by 2 mm, that is 60 mm, and z position is minus 120 by mm, minus 60. So these are the dimensions of the radiation box. Click on the fit all the content in the view. So this is the radiation box, radiation boundary. And after selecting, after that assign the radiation boundary. Select the radiation box, select the box, right click on that box, go to the assign boundary, select radiation only. So radiation box is successfully assigned. And after creating the radiation boundary, create far field radiation pattern. So create far field radiation pattern. So now here we can select the radiation, right click on that radiation, select insert far field setup, infinite sphere, and we have to select the theta values and phi values, and theta value is phi value is 0 to 360 degrees, and stub size is 5, 5, and theta value is 0 to 180 and stub size is 5. So click on the OK button. And after that set the solution setup, go to the HFSS, select analysis setup, click on the add solution setup. So now here our designated operating frequency is 2.4 GHz, that is the solution frequency. So maximum number of passes I will take 12, and maximum delta S is 0.02. This is the default value. Click on the OK button. And after that right click on the setup one, go to add frequency sweep. Okay, so now here we have to selecting fast sweep type. So for the simulation purpose it will take less time, so because of that I will select the sweep type is fast, and linear count. The minimum frequency is 1 GHz and maximum frequency is 8 GHz, and start frequency is 1 GHz and stop frequency is 8 GHz, and center frequency and operating frequency is 2.4 GHz, and I will take the number of counts are 101. So now the displays are 1 GHz to 8 gigahertz. These are the 101 count values. And after that, click on the OK button. And after assign analysis setup, so click on the check the validity of the design. So this is the validity. Click on the validity. So all are successfully validated. Now start the simulation. Click on the analyze on. So this simulation is started. Simulation is successfully completed. After completion of the simulation, we will observe the simulation results. So go to the results. So right click on this results. So first observe the S parameter plot. So create model solution data report. Select the rectangular plot S parameter S11 in dB. So click on the new report. So S parameter will be observed on the screen. So this is the S parameter plot. So now here my operating frequency is 2.4 gigahertz. Select the 2.4 gigahertz operating frequency. So now here at a 2.4 gigahertz operating frequency, the return loss value is minus 13.8 decibels. Minus 13.8 decibels. So right click on this XY plot 1, give the rename is S parameter. So now we are at 2.4 gigahertz operating frequency. The return loss value is minus 13.8 decibel. So theoretically, the return loss value is minus 10 decibel. So less than minus 10 decibel, the antenna is perfectly designed. So now we are at 2.4 gigahertz operating frequency. The return loss value is minus 13.8 decibel. That is less than minus 10 decibel. So the rectangular microstrip patch antenna at 2.4 GHz operating frequency perfectly designed. So next observe the VSWR value. So right click on the results, create model solution data report, select the rectangular plot, VSWR, select the VSWR. So click on the new report. So the VSWR plot will be observed on the screen. So this is the VSWR plot. Select the operating, mark the operating frequency. So the operating frequency is at 2.4 gigahertz. The VSWR value is 1.51. So theoretically the VSWR value is 1. So but practically its value is up to 2.6. So now where the value is 1.5. So the antenna is perfectly designed. So right click on this XY plot 1. Rename is VSWR plot. So next observe the Smith chart. Right click on the results. Go to the create far fields. Far fields. Create model solution data report. Select Smith chart. Smith chart S parameter S11. So click on the new report. This is the Smith chart. And after that, find out the radiation, observe the radiation pattern, 2D radiation pattern and 3D radiation pattern. So right click on these results. Go to the create far fields report. Select radiation pattern and gain radiation pattern. Select the gain radiation pattern and select the frequencies. Okay. So click on the new report. So now here the infinite far field setup. Click on this one. Now here the theta value is 0 to 180. So I will change this one is 0 to 360 degrees. Click on the OK button. So this is the 2D radiation plot, 2D gain radiation plot. Next, observe the directivity radiation plot. Right click on this results. Go to the create far field reports. Select radiation pattern and directivity. Click on the new report. So this is the two-dimensional directivity radiation plot. Next, observe the 3D polar plot. Right click on the results. Go to the create far field reports. Select 3D polar plot. Select gain total in decibel. Click on the new report. So gain 3D polar plot will be observed on the screen. This is the gain 3D polar plot and its value is 2.74 decibel. Next, observe the directivity 3D polar plot. Right click on the results. Go to the create far field. Select 3D polar plot and select the directivity total decibel. So click on the new report. So the directivity 3D polar plot structure will be observed and its value is 6.67 decibel. And after that, observe the radiation pattern with structure. So field overlays, right click on the field overlays, go to plot fields, select radiation field. Now we will select the 3D polar plot 1 and 3D polar plot 1 is gain and this is 3D polar plot is directivity. Select any one. So now we will select directivity and I will give the transparency is 0.85. So click on the apply button. So now we will observe the structure with 3D radiation pattern and this is the rectangular microstrip patch antenna and with 3D polar plot with structure. Next, find out the antenna parameters. So right click on this infinite sphere one. So go to compute antenna parameters and select the sweep type and operating frequency is 2.4 GHz. So click on the OK button. So these are the antenna parameters. So these are the antenna parameters and peak directivity is 6.19, peak gain is 2.53 and radiated power is 0.39 and incident power is 1 and radiation efficiency is 0.40. So this is the design and simulation results of rectangular microstrip patch antenna at 2.4 GHz operating frequency.